I'm sorry to say that I've torn my wooden scroll saw apart again. And it's only been a couple of years since I did it last. And that at that time it was to rebuild the drivetrain. I did a couple of things at that point, which was to decrease the throw and to upgrade, well, what I thought was upgrade some of the mechanics of it. At this point, 2 years later, I'm having to reconsider a great number of things about the drivetrain. And one of the things that has bothered me right from the beginning is the idea that I have a mix of metric and imperial sizes. The bearings are in metric, and the axles used are typically imperial sizes that are too small for what they're doing. So there has been wobble and wear that shouldn't be there. So in the rebuild that I'm about to do, I'm going to get fairly radical. One of the big parts about the whole wooden scroll saw idea was that it was drill powered. And I've decided that I would much rather have something that is going to be much more stable, much easier to align properly and have stay aligned. So I'm going to be using a furnace fan, which is a quarter horse, plenty of power, and it should be an improvement. I thought the last time it was an improvement. Quite honestly, the reason that I'm doing this is that when this saw is working properly, I really, really like it. But it wears, and then it gets so badly out of specification that the vibrations and things just don't work properly. And that's what's brought me to this. There are things, you may or may not recognize that as being the oscillator that makes the arm go up and down. And if you look really closely at what's happening with that bearing right there, those two bearings, they are just ridiculously worn out. And what that has done is put quite a wobble into the drive mechanism. Another thing that I have discovered that I did incorrectly on this is my counterweights are incorrectly centered, in that the moment arm between the center of that weight and the weight that it was countering is very much off. So in what I thought was putting it into balance was an improvement over what it had been previously, but it certainly wasn't in balance. So the whole thought process about the counterweights on this oscillator is improved, so that as I go through this process, I expect this to be almost right. I'm not quite sure if I am ever going to hit it right, but it's going to be almost right. And the fact is, this shaft, which is designed to be grappled by drill, is going to be replaced by the drive shaft from the furnace motor. And that's going to be permanently affixed into the oscillator. The axle here, which is an imperial size, contributing to the breakdown of these bearings, is being replaced by a 22 millimeter, an 8 millimeter stainless steel rod, which is theoretically the internal diameter of the inside of these bearings, these skateboard bearings. So that fit is considerably improved. On the lower arm, the oscillating arm, where the crank shaft pushes the arms up and down. In the last iteration, I put a stainless steel bushing in because I thought there was too much wear that was happening there. And in fact, there was so much friction involved with that the crankshaft actually wore through that stainless steel and induced considerably more vibration simply because it wore that bushing out, which is a real surprise to me. And under that circumstance, the next thing that goes in is going to be a ball bearing, so that as the crankshaft oscillates, the friction that was generated on the axle of that oscillating arm, is going to be removed because there's going to be a bearing there. So there's going to be nothing to wear out on the arm, and that means I have to make a new oscillator, and I have to remove the several pieces. The bearing mount has to go, and it's going to be replaced by a housing for the motor. So this is going to be a fairly lengthy process. It's pretty involved, but the fact is I want my wooden scroll saw back because I like it. Okay, based on my drawings here, this is the housing for the motor. And these are the pieces that I've made up for it. So that's going to be the front plate. I've laid it out, and this is going to be cut with a circle cutter. And then I need 4 holes here for the mounting bolts. These are going to be the sides. And then this is going to be a top to try and keep out sawdust away from the motor workings as much as I can. They say they don't want dust getting into it, but I think all motors are like that, and I've got lots that have a bunch of dust. Next thing are 5 30-seconds holes for the posts. Well, I think this should be it. It turns out my center hole was not quite large enough. I mismeasured that, so I had to put it on the spindle sander. And I actually went up about 1/16 of an inch on the post holes. And let's see what happens now. There we go. Okay, I want to start putting this together now. And if you notice, there's a slight difference in the dimensions of these two pieces. So that means that I have a decided bottom of the box, which I have labeled here, because all the dimensions going into placement of these holes is based on being measured against the bottom. Okay, what I'm showing here is this is the motor housing, and I believe that this is going to be its proper placement, although that's still up for some attention as I go along here. But obviously the shaft of the motor is too long, and you may recall that this is going to be my cam, and that's going to be the center that I put the motor shaft into, and then that's going to be the eccentric that drives the shaft up and down. And each of those holes is going to occupy half of the width of this cam lobe. So I want it to be very close, but I don't want it to be touching. So that's about the placement that I want. I don't want there to be really any torque on this with a long shaft going over into rod. So that means that I'm going to have to grind this off right here to make that dimension work. And I will be putting set screws in. I've got a nice flat shaft here to grab a hold of that, and then I'll make one for the next piece. So the next thing I want to do is drill the shaft holes, and this is the side that the drive shaft is going to be on, and this is a 1/2 inch hole, and it's easily centered because that's the original center of the whole thing. But what I have here is an 8mm hole that I need to drive from the opposite side of this. So I'm going to drive a 1/16 inch hole right through the center of this on the drill press, so that I can adequately start the hole on the other side in the correct place. Okay, I'm going to put the set screws in so that I can make sure that the two drive shafts stay where they're supposed to be without trying to rotate. And unfortunately, this is going to be a multi-stage process. So what I'm going to start off with is to put a pilot hole down through, and then I'm going to start off with my bit that starts a 1/4-20 thread, but unfortunately it's such a short shaft tool, it's not going to make it all the way in, so it's going to be a part way in, and then I'm going to have to finish it off with a usual manual type threading tool. Well, I'm going to spare you the ham-handed electrical stuff that I've done with this. There are a couple of shots on Instagram of the intermediate process that led me to here, but I've wired up the motor. I have my cam and my shafts located. They are not permanently in place yet, but watch this. It's beautiful. It works marvelously. Okay, this is a real fiddly piece of the work right here. This is the bearing that's going to go in here, and it's going to allow that to freely move with basically no friction. But this is a fiddly thing to do, and I figured out how to get it accomplished. And it's just about in there perfectly. And I'm just going to cut a couple of plugs to keep that centered in there. Okay, you saw that vibration. And in the last iteration, I put those pieces of steel opposite the eccentric, and it really did a lot to cut down on the vibration. And so I'm going to do the same thing, but I really don't have an idea of how much weight to put on there right now. So what I'm going to do is an experiment. This is a piece of angle iron, and I'm going to cut off several pieces of this and bolt it on opposite, so it would be bolted on here on the opposite side of the eccentric. And what I'm going to do is cut off an inch and a half. Well, maybe I'll just keep it at that and see what both of those do for me. Well, I stopped work on this for 2 or 3 days, and I've been reconsidering a lot of things about this bandsaw and its original design, and why I've been wearing out bearings, and what are the forces on it. And I've changed a couple of things, and I'm about to change another one. I went to the local home center to look at springs, and I never remembered why I pulled that spring out, but this turns out to be exerting about 9 pounds of pressure on this whole system. And clearly what that is doing is resisting the cam wheel going around. And what I've decided I really want to have is sort of a neutral buoyancy situation rather than one that's really exerting a lot of pressure over at this end of the arm. So I'm going to go to a spring like that, and this one is rated at 1.9 pounds. So that's one of the things that I'm going to do. And another thing that I'm going to do involves the cam drive again. And I've decided that the holes for the shafts were not deep enough. They only went in halfway. And so what I've done is I've deepened them so that there is just the barest amount so that I don't overdrive it. And I'm going to put 2 set screws in to each one of the shafts. And by each one of the shafts, it's this one as well, the reciprocating, and the center shaft. And the reason that I'm doing that is to try and ensure that any of the torque being applied to the shaft into the hole is going to be resisted. It's a piece of maple hardwood, but since it was only going to go in halfway, it just seemed to me that that was going to work itself loose fairly quickly. So if it's almost all the way through, that's going to give it a whole lot more resistance to the forces being applied. So those are 2 things that I hope are going to take a lot of vibration out of this system. 80 grit paper. Now I've decided I'm going to use JB Weld to put the eccentric shaft in. And I'm doing that simply because it's my understanding that slower setting epoxies are much stronger than fast setting epoxies. And ordinarily 5-minute epoxy is my choice, but quite honestly I want strength on this shaft rather than speed, and I'm getting toward the end of the day today, so having this ready sometime tomorrow is just dandy with me. And I've been very happy with JB Weld in the very few times that I've used it in the past. I've used it on cooking utensils because it's got an upper temperature range of 600 degrees, which nothing in the fast setting epoxies is even close. And I like that. And interestingly enough, I have a little flat section on this that I need to go toward the center because these two are so close that this one, if I don't have that flat section, throws off the center shaft just slightly, which is highly undesirable. I want these things to be working just dandy. It doesn't look like I put any of that weld into the center shaft at all. Although if I had, I would have just drilled it out again. And I'm going to put my set screws in. And I'm going to consider those set screws to be permanently in place now. And that looks square in both all angles that I'm looking at, which is exactly what I want. Okay, this is just a quick note to show that without any other support, the cam arm is right at the level of the motor. And you may recall that I said I wanted neutral buoyancy, and that's what I've achieved right now by adjusting this spring simply by adjusting the length of the connecting wire that I've got there. Took a couple of minor adjustments, but that's exactly what I want to achieve here. Neutral buoyancy. Well, this is several days later, and I wanted to show you what's going on here. I had to actually make another cam and set this up because the one that I showed you earlier that I said I had set in perfectly square did not end up perfectly square. It's really canted off to a side, and I was baffled by that. So I made up another round, drilled the holes, put them in with the JB weld, and left it for a couple hours, and I came back to take a look at it, and it was bending over again. And I was completely baffled by that. So I put that clamp on to put it back in square, and I'm just using this to show that it's actually square. And that was yesterday, so I'm assuming that it is now doing well. But the other thing that I decided to do that I probably should have done right from the start was to make sure that the center was well fortified, because these two drillings are so close together that there's clearly a weak spot right there. So I used 1/2 inch outside diameter copper tubing to make sure that that was working well. And so that's what I've ended up with. And that's a pretty nice looking post right there. I think I've got my square post. It's taken a couple extra days to get there. But I just wanted to warn you that something, I've never seen that before. Something really weird happened, and you just got to keep looking at it. Well, I'm ready to go now. And
I've put these brackets on to avoid having to turn this over and screw the housing down from the bottom. This motor is pretty heavy and it's really difficult to position it properly, so this is very solidly in place. This seems to be doing very well. I've got enough tension on there. It turns over very nicely. I have a little counterweight, and all that counterweight is doing in my mind right now is counterbalancing that piece of metal. Otherwise, the arms are in balance with this small spring back here. So we'll see how it jumps around. Previously, I actually had to screw this down to my bench to make sure that it didn't hop off. And that's one of the screws that would hold it down. But I'm looking forward to not screwing it into the bench, so let's see what it does. And we'll give it a try. That's so sweet, it's stupid. Oh my goodness gracious. What a delicious change that is. Now I have to find a way to house up all of these wires back here, but that is just wonderful. Well, it's been a little while since I had a video up. I've had my health issue. It's been a tough haul. A couple of months in. I still have some healing to do, but I expect it's going all right. And you saw me run the saw, and it wasn't clamped down to my desk, my workbench, and it was great. So right now, I think that I've finally staggered onto a very good DIY scroll saw. And it's taken something on the order of close to 4 years, it seems to me at this point. But I'm really happy with where it is now. And those of you who stayed with me through this incredibly torturous working relationship with my tools, I thank you very much, and please give me a like and come on back and see me the next time. I'm Tom Stevens. Yeah, pretty soon I'm going to have something else, but you never know when. Thanks a lot.